China is transforming ideas once thought to belong only in science fiction novels into reality. Record-breaking overpass bridges, connecting treacherous mountain ranges, smart cities monitored and operated by real-time data, agriculture nurtured by fleets of autonomous drones, and classrooms where professors can appear through cutting-edge hologram technology. This is not just infrastructure development, it's a comprehensive leap forward where technology, engineering, and massive scale combine to revolutionize how a nation functions. Join Top 10 Discoveries official to explore these groundbreaking advancements right now. Over the past 3 decades, China's extraordinary transformation in the fields of engineering and technology has not been a matter of chance, but the outcome of carefully crafted, long-term strategic policies. Following the era of reform and opening up, the government pinpointed infrastructure and advanced technology as the cornerstones for sustaining rapid economic growth while strengthening the nation's standing in the global value chain. As a result, enormous investments have been consistently channeled into sectors considered pivotal for the future. A clear illustration of this vision is the Made in China 2025 program, launched to position the country as a global leader in high-tech manufacturing, reducing dependence on imported technologies in critical industries such as aviation, renewable energy, medical equipment, and information technology. Running parallel to this, the Digital Silk Road Initiative fosters cross-border digital infrastructure and data connectivity, extending China's technological influence far beyond its borders. These strategies prioritize not only tangible production, but also the creation of a robust digital ecosystem, where data and artificial intelligence serve as the lifeblood for progress. To achieve these ambitions, funding for research and development has seen steady growth. Currently, R&D expenditure accounts for roughly 2.5% of the nation's GDP, translating to hundreds of billions of dollars each year. This investment places China among the world's fastest-growing spenders on research, with a focus on strategic areas like artificial intelligence, renewable energy sources, advanced materials, and massive-scale infrastructure. By allocating resources in a concentrated, large-scale manner, China has launched numerous mega-projects that resonate on a global stage. Another key element is the method of organization and implementation. Instead of pursuing scattered initiatives, China employs an integrated approach. Macroeconomic policies, state-owned enterprises, private companies, and research institutions collaborate seamlessly. This creates a self-contained ecosystem where innovative ideas are tested, scaled up, and swiftly applied in practical settings. From high-speed rail networks and ultra-long bridges to ultra-high voltage power grids and cutting-edge digital technologies, all are driven by a unified principle: develop rapidly, on an immense scale, and compete with the world's highest standards. Evidently, extreme industrialization is more than just building massive projects. It represents a core philosophy of development. It's how China tackles internal challenges such as its vast population, enormous energy needs, and the urgent demand for modernization. At the same time, it serves as a powerful instrument to expand global influence in an era where technology and infrastructure are benchmarks of a nation's capability. When it comes to Chinese engineering, transportation infrastructure stands as the most striking evidence of transformation in scale and speed over the past 2 decades. The nation has constructed a high-speed rail network spanning more than 28,000 miles, equivalent to over 45,000 kilometers. Accounting for roughly 2/3 of the world's total high-speed rail length, this system serves billions of passengers annually, significantly reducing travel time between major cities while boosting economic development in remote regions. This is an achievement unmatched by any other country on a similar scale. Alongside railways, record-breaking bridges have become symbols of China's ambition to exceed standards in engineering. The Huajiang Grand Canyon Bridge in Guizhou, with its decks soaring approximately 2,051 feet above the river below, ranks among the world's tallest bridges. In Guangxi, the Tianyi-Longtan Bridge holds the record for the longest arch bridge globally, with a main span of 1,968 feet, while the Pingnan Third Bridge boasts an arch span of 1,837 feet. These structures demand sophisticated construction techniques in challenging terrains and showcase the ability to optimize new materials and advanced assembly methods. Beyond road bridges, numerous railway bridges have been built to support high-speed rail lines. The integration of bridges, tunnels, and long-distance tracks has turned mountainous provinces like Guizhou into a natural laboratory for complex engineering solutions. Engineers employ concrete-filled steel tubular structures, temporary cable-stayed systems, and digital monitoring technologies to ensure safety throughout construction. Horizontally, projects like the Huajiang Bay Bridge and other sea-crossing endeavors demonstrate that China conquers not only height, but also length. These bridges, stretching dozens of miles, connect coastal industrial hubs, shorten freight transport times, and promote international trade. The highway system has also expanded rapidly, with over 100,000 miles, 160,000 kilometers spanning the country, the longest network of its kind worldwide. It serves as a vital artery for transporting goods and linking production centers. Combined with high-speed rail, this forms a rare dual backbone logistic structure unmatched by any other economy. All these projects reflect a familiar philosophy. Infrastructure development is not just about meeting current needs, but about creating long-term competitive advantages. Owning numerous record-breaking bridges in a dense transportation network shows China's relentless pursuit of setting new global engineering standards, aiming to serve its people while asserting superior capabilities on the world's construction technology map. One of the most striking pillars of China's engineering ambition lies in its energy sector. With a population surpassing 1,400,000,000 people and an enormous appetite for electricity, the nation has engineered a system vast enough to meet today's demands and resilient enough to sustain future growth. Consequently, a series of monumental energy projects have been constructed, serving as enduring symbols of a strategic, forward-thinking development vision. The standout example is the Three Gorges Dam on the Yangtze River. This colossal project has an installed capacity of approximately 22.5 gigawatts, generating enough electricity to power tens of millions of households each year. When completed, it claimed the title of the world's largest hydroelectric power station, delivering not only a stable electricity supply, but also critical flood control and enhanced navigation for inland waterways. Managing such a massive volume of water presented intricate technical challenges, yet it showcased the exceptional project management capabilities of China's hydroelectric industry. In parallel, China has prioritized ultra-high voltage UHV power grids. This cutting-edge technology enables the transmission of electricity at exceptionally high voltages, efficiently delivering wind and solar power from the resource-abundant, sparsely populated western regions to the bustling industrial and urban centers in the east. With this system, electricity can travel distances exceeding 1,200 miles with minimal energy, loss of feet that even many advanced nations, including the United States, have yet to achieve on such a grand scale. Furthermore, offshore wind farms and solar power facilities, each with capacities reaching thousands of megawatts, are being rapidly developed. Projects like the Tengger Solar Field and the Jiangsu Offshore Wind Park have significantly boosted the proportion of renewable energy in the national energy mix. Currently, China commands more than one-third of the world's renewable energy capacity, cementing its position as a global leader in sustainable energy solutions. This energy ambition extends beyond mere production to encompass storage and intelligent management. State-owned and private enterprises are pioneering grid-scale battery storage systems integrated with artificial intelligence to optimize power load distribution. This technology reduces risks of supply imbalances while driving down production costs. All these initiatives are geared toward securing energy independence and advancing commitments to reduce carbon emissions. Beyond addressing domestic needs, China aims to export its clean energy innovations from wind turbines to UHV grid systems, positioning its energy sector as a cornerstone of global influence in the era of the green energy transition. In its modernization journey, China is not only constructing bridges and power plants, but also revolutionizing how cities operate. The concept of smart cities has been implemented on an unprecedented scale, transforming urban centers into living data hubs, where activities from traffic to environmental conditions are monitored and optimized in real time. A prime example is Yinchuan, located in the Ningxia Autonomous Region. Here, widespread surveillance cameras and facial recognition systems manage building access, monitor traffic flow, and assist security forces. These systems go beyond alerts, analyzing behaviors to provide recommendations for preventing incidents. The city's control center acts as a brain, processing millions of data points daily with remarkable speed. Beyond security, smart cities prioritize energy and environmental management. Sensors deployed throughout urban areas measure air quality, electricity, and water consumption, delivering real-time insights to authorities for swift action. When air pollution exceeds safe levels, the system can automatically issue public alerts and suggest restrictions on private vehicles in specific zones. Notably, big data from mobile devices enables cities to predict population movements. This optimizes public transportation, allocates healthcare services, and even forecasts consumer demand. With roughly 30 billion location-based requests daily from mobile devices nationwide, China leverages data as a strategic tool to enhance urban efficiency. To date, over 200 cities have adopted partial or full smart city models, making China the global leader in high-tech urban pilots. These projects are tightly integrated with infrastructure, from railways and overpasses to fifth-generation telecommunications networks, creating a holistic operational system. However, this model introduces challenges, particularly regarding privacy and data governance. While many praise the efficiency and safety benefits of these technologies, concerns arise about the extensive scope of surveillance. This duality makes China's smart city concept a global discussion topic, technically fascinating, yet socially complex. In summary, smart cities are more than modern management tools. They embody China's ambition to make technology the brain, orchestrating urban life. This approach is setting new standards for the 21st century, redefining how cities function worldwide. While China's urban centers grow increasingly smart, its rural areas are undergoing an unprecedented transformation driven by technology. With only about 7% of the world's arable land yet tasked with feeding nearly 20% of the global population, boosting agricultural productivity is a matter of survival. To tackle this challenge, the nation has heavily invested in a suite of advanced solutions, including drones, robots, and cutting-edge gene editing technologies, revolutionizing traditional farming practices. Drones have become the most widespread tool in the fields. Instead of manually spraying pesticides or fertilizers, farmers now use unmanned aerial vehicles equipped to map fields, measure soil moisture, detect pest issues, and precisely apply treatments to specific areas. Modern drones adjust flight paths based on wind data, speed, and terrain, ensuring maximum chemical efficiency with ultrafine droplets under 100 microns. This approach minimizes soil and water pollution while enhancing crop absorption, promoting sustainable farming. Complementing drone technology, specialized agricultural pilot training schools have emerged. These institutions certify thousands of operators annually, turning drone piloting into a new profession. Statistics show that tens of thousands of licensed pilots are now active, directly supporting the mechanization of rural agriculture and boosting efficiency. Robots and sensors are also being integrated into modern fields. Automated machines collect real-time data on temperature, humidity, and crop growth rates. Paired with artificial intelligence, these systems provide precise recommendations for irrigation, fertilization, and harvesting schedules, reducing waste and significantly increasing yields. Another critical focus is gene editing research. Technologies like CRISPR and other genetic modification methods are being tested to develop drought-resistant and pest-tolerant crop varieties. These advancements address climate change and the shrinking availability of farmland, ensuring long-term food security. These efforts are closely tied to e-commerce. Taobao villages enable farmers to sell products directly through online platforms, transforming rural areas into vibrant commercial hubs. Technology thus not only enhances productivity, but also expands market access, boosting incomes for millions of rural households. Broadly, high-tech agriculture has become a cornerstone of China's engineering strategy. The integration of drones, robots, big data, and gene editing not only addresses domestic food demands, but also opens opportunities to export agricultural technology to developing nations. This showcases how China turns resource constraints into a platform for asserting global technical leadership. In the grand tapestry of Chinese engineering, digital technology serves not only as an industry, but as the foundation binding society together. With over 1,100 million internet users, the vast majority accessing the web via smartphones, digital platforms have become the primary space for the daily lives of hundreds of millions, from shopping and payments to communication, healthcare, and entertainment. Everything is seamlessly integrated into super apps. A prime example is WeChat, a versatile application that combines messaging, voice calls, payments, doctor appointment scheduling, ride-hailing, and even personal record management. This structure creates a comprehensive digital ecosystem where every transaction and interaction generates valuable data. Alongside platforms like Taobao and Douyin, countless other apps have transformed consumer habits into a continuous stream of information, offering deep insights into public behavior. The most striking highlight is Singles' Day on November 11th. This shopping event now surpasses the combined scale of Black Friday and Cyber Monday. Within a mere 24 hours, hundreds of millions of orders are processed, generating an immense volume of data on products, pricing, and purchasing patterns. E-commerce companies analyze each transaction to refine advertising campaigns, optimize supply chains, and even predict consumer trends for the following year. This isn't just a shopping day, it's a national-scale data experiment. Another transformative field is live stream commerce. These interactive selling streams have grown into an industry worth trillions of yuan, attracting hundreds of millions of daily viewers. Hosts showcase products while engaging directly with audiences. As payment and delivery systems process orders almost instantly, the speed and personalization of this model outpace many traditional retail approaches, redefining how consumers shop. More significantly, the vast data collected extends beyond commerce. Artificial intelligence algorithms analyze consumer behavior to develop new products, identify high-potential markets, and adjust pricing strategies. With approximately 30 billion location-based requests daily from mobile devices, China can track not only what people buy, but also where and when they buy it. As a result, consumption has become a data goldmine, providing businesses, policymakers, and tech developers with an unprecedented wealth of information. Consequently, Chinese society increasingly relies on data analytics, turning individual behaviors into a driving force for shaping national strategies and fostering a hyper-connected, data-driven future. If China's robust infrastructure and thriving e-commerce sector highlight its economic prowess, its advancements in immersive technologies reveal how the nation is revolutionizing the digital lifestyle. Over the past few years, virtual reality, VR, and augmented reality, AR, have transcended their experimental roots, evolving into a dynamic industry that serves millions of people across diverse applications, seamlessly blending cutting-edge technology into everyday experiences. Across the country, VR entertainment centers have surged in popularity, with more than 100,000 arcade rooms established nationwide, welcoming millions of visitors each year. A prime example is the immersive VR experience at Shanghai's iconic Oriental Pearl Tower, where users can soar through virtual cityscapes, navigating skyscrapers in a breathtaking digital environment. This innovative attraction not only delivers thrilling entertainment, but also makes advanced technology feel accessible, relatable, and deeply integrated into daily life for people of all ages. Both private enterprises and major corporations are pouring significant investments into this sector. Motion Magic, a leading innovator in VR development, has pioneered multi-lens camera systems capable of producing high-quality 360-degree films. These cutting-edge systems are not limited to entertainment. They're transforming industries like virtual tourism, real estate visualization, educational platforms, and even healthcare simulations. A key factor in this expansion is the rapid development of affordable, user-friendly VR hardware by domestic companies, which has democratized access, extending the technology's reach beyond the urban middle class to broader demographics across China. In the realm of e-commerce, VR is redefining the shopping experience. Alibaba's groundbreaking Buy Plus platform allows consumers to step into virtual stores, interact with products in a three-dimensional space, and complete purchases within the same immersive environment. Paired with China's ultra-efficient, high-speed logistics network, this technology enables a seamless transition from trying a product virtually to receiving it in reality, often within hours. This innovation elevates online shopping from a flat, screen-based process to a fully engaging, interactive journey. AR applications are equally transformative, finding widespread use across multiple sectors. In tourism, travelers can point their smartphones at historical sites to see digital overlays of past events or architectural reconstructions, enriching their understanding of cultural landmarks. In education, AR tools enable students to visualize complex concepts, such as the structure of the solar system or intricate biological molecules, fostering deeper engagement with learning. These applications have moved technology beyond entertainment, establishing it as a powerful tool for education and research. The most remarkable aspect is the rapid mainstream adoption. While many Western countries still treat VR and AR as niche markets, China has embraced them as core components of its consumer culture. By integrating these technologies with social media platforms, online gaming, and e-commerce ecosystems, China has built a global-scale digital entertainment industry. This fusion creates a new benchmark for how technology can directly influence the daily lives of hundreds of millions, reshaping global standards for immersive experiences. Not only focused on its domestic market, China is aggressively expanding its engineering expertise worldwide, from Africa and South Asia to Europe. Projects involving Chinese companies and technical institutes have become symbols of global ambition. A clear example is in bridge and road construction. China holds records for many of the world's longest and tallest bridges, but its influence extends beyond its borders. The Çanakkale 1915 bridge in Turkey, the world's longest suspension bridge, was built with significant contributions from Chinese corporations and engineers in design and construction. In Africa, China has invested in and supported the development of numerous high-speed rail lines, such as the Addis Ababa-Djibouti Railway, which is reshaping regional transportation systems. Major construction giants like China Communications Construction Company, CCCC, and Power China consistently secure bids for critical international projects. Beyond providing skilled engineers, they bring advanced data management technologies, structural design software, and innovative material solutions. This enables China to export its technology-integrated infrastructure model, where construction, monitoring, and operations rely on digital platforms. In the energy sector, hydroelectric and renewable energy projects further highlight China's leadership. The Grand Ethiopian Renaissance Dam in Laos and offshore wind farms in Europe involve Chinese contractors on a massive scale. Notably, ultra-high voltage UHV power transmission technology, considered a hallmark of Chinese engineering, is being implemented in countries seeking stable power grids. This growing presence carries dual significance. Economically, it allows Chinese firms to expand market share and strengthen their position in the global value chain. Technically, it sets new benchmarks as domestically developed technologies become international standards. The ability of a Chinese company to construct a record-breaking bridge in Italy while simultaneously tunneling through mountains in Pakistan demonstrates that China now rivals the established engineering giants of Europe and the United States. This trend reflects a shift in the global engineering landscape. Where Western names once dominated major infrastructure projects, China is now a central player. This transformation didn't happen overnight. But with the current pace and scale of investment, China is undeniably reshaping the global infrastructure and engineering map. What are your thoughts on this topic? Share them in the comments below. Don't forget to hit subscribe to stay updated on the latest analyses of technology, national strategies, and innovations shaping the future. Top 10 discoveries. Official will return with untold stories, projects that defy limits, and quiet revolutions with global impact. See you in the next video.